Hey, good morning, everyone. This is another video on going over some of the content we did yesterday, March 23rd. The assignment was about energy of a mechanical wave and how it's related to amplitude. So we were supposed to do the reading of this document, which you can see on your screen. It was attached in the newsfeed and it's also in the DLD folder. Once you get there, you were supposed to answer a couple of questions first and then complete a Google form. I'm not showing a Google form here. You can always go ahead and do that if you need to. I'm just going over the questions which were commonly missed, and I think there was one error in the answer key, so I apologize for that in advance. But based on what I saw, I could tell how many of you got. So this is just a cumulative review from what I saw in the Google form, which most of you missed. So one question in which either two parts were answered correctly or one, and then this was the one where one of the options was incorrect. So I'll just quickly go ahead and give you the answers as we go over this, and that will also help those who haven't done the assignment and would like to go ahead and make it up. That will help them too. So one question was, Macintosh stand 8 meters apart and demonstrate the motion of a transverse wave on a slinky. The wave can be described as having a vertical distance of 32 centimeters from trough to crest. So we all know that if we are having the vertical distance of from trough to crest, that means from top to bottom, and there's a midline in any wave in between. That being said, that this simply means if I'm looking for the amplitude will be half of that distance. So it will be 16 centimeters. I'm just writing my answers here. And the next one was saying frequency of 2.4 hertz. Remember, students, we have learned that time period is inverse of frequency. It's 1 divided by f. That being said, if I'm looking at that, period would be 1 divided by 24. That means so 1 divided by, which is also equals 1 divided by 2.4, and that gives me the answer of period being 0.41 seconds. Another thing was, question was asking for wavelength, and wavelength we know is distance from crest to crest. So when we go from one crest to another crest, there is a trough in between. So if I'm doing that, if you then it turns out that 48 centimeters is just half of the distance, because from crest to trough, that's half of the wave, and then another crest comes. So that will be next half. So overall 48 plus 48, or 48 times 2, that gives me 96 centimeters. These were the answers for that particular question. I won't go over number 2 and 3. Most of you, those who participated, did very well. If was just one student missing it, I might just reach them out separately, because I don't want to give out all the answers. The next question which several of us missed was, based on what we read just now about pitch and frequency being the same, is there any relationship between wavelength and pitch of the sound? Remember, one thing we know for sound wave, pitch and frequency are the same thing. Pitch is a new vocabulary word we happen to use only and only for sound wave, not for any other wave. Frequency we know means number of cycles each second, but for sound we call it a pitch. So high pitched means high frequency sound. Low pitched means low frequency sound. So now here question is not talking about pitch and frequency. Question is talking about pitch and wavelength. If I replace pitch with frequency, then I'm looking for relationship between wavelength and frequency. And we learned that earlier. Wavelength and frequency are inversely related. So many of you said they are the same thing. Remember, frequency and pitch are the same thing. Question was talking about pitch and wavelength. So I know it could have been confusing if we rushed, but make sure double check. Remember, longer the wavelength, smaller is the frequency, because they are inversely related, and you can always find this relationship using velocity equation. Velocity of the wave is given by frequency times wavelength. So let's see, times wavelength, you know, the symbol is lambda, and it's so if you will increase the frequency, wavelength goes down. If you increase the wavelength, frequency goes down, because velocity of wave would not change by changing frequency and wavelength alone. We have talked about those things, so just keep in mind these are the things we have to know. Another question which several of you missed were reflection of a sound wave. Sound waves reflect off a surface commonly known as an echo. I think this is something which we know even before I teach it, because most of you know that. Sound must be at least 20 meters away for us to detect an echo. So for this, we end up, question was, how many seconds is this if sound travels at 340 meters per second? So what's given to us is speed of sound. So for this, we will use, okay. So if I'm using my old school equation, because I have a distance given, velocity given, so I'm looking for time, all we do is just rearrange it. Time would become distance over velocity, or displacement over velocity, we can say. So all we do is just plug in the numbers. This gives me displacement is 20 divided by 340 meters per second. So when you do this division, our answer for time comes out to be in decimals, because it's going to be very small amount of time. We are looking at how much time sound took to get to the point where it echoed from. So my answer was 0.0588. Now in this question, I felt most of you didn't rearrange the equation properly. Students, this is a skill we have to know. It's a basic algebra, basic math skills. We have been talking about this since August. So getting from here to here is fairly simple. All you need to be just make sure you know how to do that. That's all. Okay. Let me know if you have any questions. And this is it for from yesterday. Okay. Thank you so much. I hope this helps. Have a great day, y'all. Make sure continue participating in DLDs. We have a quiz coming up tomorrow. That will be the last assignment before break, spring break. Quiz will remain open till March 30th. But yes, that means you can complete it by then, but you won't get any feedback if you do it over spring break. Usually I am available during school hours. I start morning 8 till 3. And so if you happen to ask any question during that time period, I will try to reach you out. But it may take some time, because I'm not sitting in front of my computer all the time, but I do get back to students really soon. But if you're asking questions over spring break, sorry, I won't be available, but I will definitely get back to you once I'm back from spring break. Feel free to ask questions. I won't mind if you post or email those to me, but I won't be available over the spring break. Thank you so much. Have a great day, y'all. Miss you all. Thank you.